Okay, so what's the sound like? Hello? Test, test, test. I hope it works. Also setting the category. Yeah. Well, where do you do that? On Twitch. Edit. Category. Software. Good. So I need the chat. Okay. Okay. So, welcome to the stream. It's been quite a while since the last time I was streaming. This is the first time we're gonna stream to Twitch as well. So, let's see how that goes. I'm trying to do this more regularly. Trying to prepare something for stream, and then following up on the stream with some interesting topics, at least interesting to me. Today, we're gonna look at Odin, the programming language by Ginger Bill. It has a lot of nice concepts inspired by Jonathan Blow's language and Go, I guess. At least that's what I heard. I didn't really do anything with Odin to this point, so I'm kind of excited to see what it's like and take a look at the design decisions, what it incentivizes us to do, and whether that aligns with what we want from a programming language, from a low-level programming language. I'm streaming from my Mac. That means we're kind of bound to what Mac allows us to do. It oftentimes is very restricted, but let's see whether that is a problem or not, because we're just poking around the language today. Maybe we're trying to start something with a little socket and sending messages, but nothing too fancy. So I have looked at the GitHub repository, as well as the one second, Odin Lang, as well as the website, as to what it claims to have. I looked at this overview page, not too much. So I just skipped through it, and yeah, I don't know if it's a good idea to just take a glimpse at this entire page. I believe it's pretty extensive. So it has a lot of the language features. Maybe it's worth it looking at this. I don't know. But what I wanted to see was, or what I wanted to look at was the examples. The examples provided by the language in the GitHub repository. So I saw that it has this examples folder, and in it are a lot of things. Like, was it that? Is it the same repo? What is that? Odin. Oh yeah, okay. So it has its own repository for examples. So the language is in this repository, and there is a repository just for examples. And I wonder whether the demo thing is also in here. It doesn't seem like so. Okay. So I wanted to look at this demo file first, because it has a lot of the language's principles in it. See examples. Okay, so that's the examples and that's the demo. So the demo is in the Odin repository. That means we first take a look at this Odin demo file. And see what it provides to us. Oh my God, please. Thank you, sir. Okay, so let's get started. I already cloned this. I should probably I should probably, so that's this repository. I should probably clone the examples as well. GitHub.com, Odin lang, and examples is it, I suppose. Okay, we should look at the examples as well, but first and foremost, we look at the demo, which should, in theory, provide us with all the language constructs that we sort of need. But it may, due to the fact that it's one file that contains it all, it might be hard to get to look at the features in particular and kind of isolate a feature and run it. Yeah, but let's see if we can find the file. So its name was demo.odin. No, not .f, it's -name. Okay, so in examples, demo.odin. Okay, let's make it okay, let's open tmux. Is it possible to increase examples demo.odin? Okay, let's first make it a little bit bigger. .config alacrity. There's probably a way you can do this you can make this better. Yes, but I don't really know how you can increase the font size and alacrity. So that's just what we are left with. Okay, let's see if I wanted to see whether the text is big enough. Because for me, obviously, it's big enough, but on the stream, I'm not so sure. You know, also, let's make this full screen. Okay, maybe we can make this even bigger. So make this 18. Okay, 18 seems good, I guess. If it's too small, we will see how it goes. Okay, let's look at this file. So Odin is a general purpose programming language with distinct typing built for high performance. Okay. I saw this distinct keyword before, which is for type declaration as far as I know. I don't really know whether... I mean, in C you can do type def uint32t u32, right? And there you can use them interchangeably. You could also say we have a struct, and that is a two floats. Oh man. And that has a float first and a float second. And you could also type def two floats, vector 2. And you could use them interchangeably. That is, you can call functions. I believe you can call functions. Okay. I don't know. So let's quickly verify this. So my hypothesis is that you can call functions that take two floats with vector 2 as well. Let's see if that works. So let's make a quick C file, and let's just say void two floats vector add, and we have a struct two floats that has a float first and a float second. And it just two floats first, two floats second. Yeah. Two floats result is equal. So result dot first is equal to first dot first. Okay, the naming is kind of bad, but you get it. Dot seconds equal first dot second plus second dot second. Bad example. You might not even want to return this, but probably it's getting in line as well. But okay, so we have two floats first. let's call it A. Let's call it A and B. Okay, A, B. Two floats, and this is equal to 1.OF and 2.OF. And we also have a B. That's 3.OF and 4.OF. And now we want to add two floats. C is equal to add A and B. Now we want to printf C dot first and C dot second, which is a percent F. So this should compile. So clang test.c. Oh yeah, okay. Have to type def struct two floats. So here's already a type def involved. Or we can also do is put a struct in front of this. Yeah. Oh yeah, of course we forgot to include standard IO. A.O. Okay, we see 4 and 6, what we expect. But now, if we say type def two floats and vector 2. Let's stick with the convention. And then we say we have a vector a vector 2 a vec 1.OF 2.OF and let's say we have a vector to cvec, add avec, bvec. Oh, okay, messed it up with the macro. Does this compile? This just compiles. So we can pass in a vector 2, although this function expects two floats because they are essentially the same. In Odin they introduced this keyword called distinct. They introduced distinct. So if we would use something like distinct here, I mean the syntax is obviously different, but if we use a distinct here, this would no longer be possible. You would have to have another function. This obviously doesn't work because C doesn't allow for operator overloading. But if it would allow that, we would have to create a new function that's like this. But C just doesn't care. We type def that it doesn't matter. It's the same thing to C. So we don't have to do that. But this can obviously be a little bit confusing. So you might want to use this distinct keyword, which is obviously not available in C. So let's get back to our examples demo.odin. So this is with distinct type with the sync typing build for high performance modern systems and data-oriented programming. Wow, we are already a lot of minutes into this, I believe. And we only read one sentence. So installing Odin, we did that, blah, blah, blah. Okay, we don't read this. The basics. Okay. So Odin, for printing, we already see we have a format library. How this importing exactly works, I don't know. And what all of this here means, plus VET, using statement, using param, plus feature, dynamic literals. This is probably telling the compiler to use some features, but I'm not sure. V plus VET. Okay, so plus feature, kind of obvious, but plus VET, I don't know what that means. Okay, so we have scopes that begin with the curly brace. It's good to know. And okay, you have a print line. And then you also have os.args. I wonder how they implemented os.args. And what os.args really is. So it is an array. And you could, this is like Python, really. This is really like Python or Go. So you have this length function that can be called on something that has a len attribute. I don't know. So if you have something like a struct thing and it has a length, and it may have a length, U32 length. Can you call length on this? I don't know. But somehow you can call length on things. Okay, this is more like an introduction to the syntax. I really like to see something that shows the differences to C, because in C, at least if you use the C runtime library, and have your main function with the args. The args are the arg values are pointers to pointers of characters, and they are null byte terminated, as expected from the C specification. But in this case, I don't really know. So this is obviously, this has the length, so the arg count, and the values in them, which is probably a string, and the string in Odin, I believe, is a pointer and a length. But I don't know. We'd have to see that. And I would wonder how they allocate this, what's going on before the execution of the program that allows them to have os.args here. I believe you also have to import this. Yes, okay. So I'm kind of interested in how they implemented that. We would have to look it up. But honestly, but obviously, I believe we don't have something like the C runtime library. I mean, obviously we have something that runs before main, but that's not going to be the C runtime library. Something that fills in this os.args. Okay. So this is now the lexical elements. So we have ints. I wonder what an int is. Is it like int and C, which can be multiple things? But most of the times 32-bit signed integer. Okay, comments can be nested. Great. String loaders all enclosed. Yeah, just like any other language. So what I already see here is that, okay, we miss on a lot of tokens. So they omit, for example, the parentheses and the if statements, I believe for loops as well. And they don't have semicolons. Which means you cannot do something like this. I guess that shouldn't work. So Odin build demo. Yeah, that was stupid. So Odin build. I guess you do it like this. Demo Odin dash F file. Okay, this builds. So you can use semicolons. This should not work. Yes. Okay, so you can use semicolons, but you don't have to. That's interesting. I mean, but obviously this shouldn't work. Yeah, this doesn't work. So you have to provide the semicolon if you want to put two things into the same line. So I believe in for loops, for loops should use semicolons, right? Yeah, for loops use semicolons. Can you do for loops in multiple lines? Like this. Is that possible? Okay, it's not possible. That's kind of... where's a control flow? I don't know how to feel about this. If I add parentheses, does that change anything? No. And also, why does this show up? Kernel 32. I have no intentions to use any of this kernel 32 code. Why does it show up with each error? That's kind of annoying. I don't want this to show up. Maybe it's because of the features, I don't know. Maybe it's because of Mac OS. Okay, so this doesn't work. Does this work? Okay, this compiles again. Okay, too many fours. This compiles, so you can do multi-line. But how about, so if we have another variable k, can I increment k as well? No. I cannot increment k as well. Okay. That's kind of unfortunate, but honestly, you don't really need that. You can just put it into the body. And see, I sometimes did that. Okay. Okay, let's go back up. So we have integers, right? A, B, you can also have, okay, these assignments. That's kind of nice. Multiple variables. You can have, can you have shadowing? That's kind of, okay, let's, so I believe you do it like this. This is a type declaration, colon, colon. So we say this is a procedure, and we also have to declare a package, I guess. And packages are on folder level, if I recall correctly, but we'll see that. We'll see that in a second. Okay. Go back. Sorry. Okay. I believe we can see that. So we could also import. Was that the right syntax? core.fmt and fmt.println. So now I forgot what I wanted to do. What did I want it to do? Dang it. This is a string. Oh yeah, shadowing. I wanted to look at shadowing. So if we have one variable, a, and this is a is now a string. And now we declare another a, which is an int. Does that work? Is a keyword. Is it like this? Now redeclaration. So shadowing is not possible in Odin. I don't know how I feel about that. Core reflect. I don't know how I feel about that. Okay, so, okay, colon, colon is constant. Constant declaration. Okay. X has the untyped string value what? Why is it untyped? It clearly has a type if it says string, right? So constants can be explicitly typed like a variable declaration. Oh, okay. Constant computations are possible. Okay. That's kind of weird. So most languages have a const keyword. Or the other way around, they have a mute keyword, like Rust. But this is kind of weird. But okay. Interesting decision. I wonder why they did that. But okay. One second. Right. So control flow. Let's see. So for loops, we see, okay, we can declare some variable. We can have a check whether we should continue the loop or not, and we can also have this statement here. I wonder if we can do something like this here with I, also k plus equals 1. Demon. No. Oh, undeclared name. K plus equals 1. Oh my goodness. Redeclaration. Oh my goodness. That is stupid. Odin. Redeclaration? Oh, of course. Oh my goodness, please. Undeclared name I. Why is it undeclared? Because it goes into the scope? No. Undeclared name I declared that. Demo. Odin builds demo.odin file 156. Huh? Okay, what is that? What does that do? Okay. Okay, we have a K. We have 4 I is less than 10, and then we have a scope. I plus equals 1, K plus equals 1. And now I wonder. Oh, I believe it. Whoa. I believe it takes this as the body of the for loop, right? Is that what's happening? But why? Oh yeah, okay, so this is separate. This is now separate. So I is not available in here. That makes sense. But can you declare multiple things? IK. I believe you can do that. Main.odin. Okay. But why can't you do an increment on both of these? Can you do something like this? Okay, that would be ridiculous if we could do that. Yeah, that's not... What? I mean, that's so weird. Plus equals 1. Why can't I do this? Okay, you can only do 1. You cannot do 2. But you can assign 2. Yeah, that's okay. I don't care. Let's see if the demo file isn't built now. So that's the basic loop. There are no parentheses surrounding the three components. Yeah, okay. Blah, 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 blah. Okay, there's also something. There's also do. So if you want it in one line, you can also put a do there. Is that right? A tree sitter. What was it again? How do you install tree sitter nvim install? TS install, was it? What was it? TS install Odin? No. Okay. Doesn't matter. Okay. So this 4, this can be dropped. So they completely omitted. Wow. They do everything with 4, which is okay. But if you have only 1, I believe it has to be the condition. Okay, you can even omit the condition, and it's an infinite loop. That's cool. Probably easier to parse as well. So I guess that's not really the reason, but because how hard would it be to just add another keyword? But it's also nice. Okay, you can also do something. Okay, that's interesting. They have so much syntax variation in this for loop. So this is less than 10. So this is not inclusive. And you can also have equals. So this is somewhat like ranges in Rust. Okay. These things can be iterated over. Okay. I believe in Jai you could also just have implicit iterators, an implicit index here. So you could just say IT here. I believe that's not possible in Odin. You would have to do something like IT here. Yep. Okay. But I wonder which one it is. So we have a string, hello world. Oh, you can also do this string, hello world. For, okay, already doing the parentheses, right? So for char IT in, let's call it C, in hello world, fmt.print ln itc. Let's see which one it is. Does it do it? Yeah. Okay. So I have to, the second one is the iterator. You also have arrays, which is great. And you also have slices. So I believe a slice is just a, obviously arrays have a static, arrays have a static size, a size that's known at compile time. So the compiler knows how big this thing is. We only have to store the pointer here because the rest is known at compile time. But slices do have a runtime size, I believe. So I wonder what the slice syntax is, how you get a slice from an array and so on. And you can also have dynamic ints. So dynamic list. That means they have an allocator backed in here. So I know Odin has some implicit context, which has an allocator. I don't know what the default allocator is, but I wonder if they have it's just calling some malloc thing, some general purpose allocator, or what it's doing. Because if you delete things, I mean, dynamic arrays are not that simple because they have to be contiguous. So when the size that's been allocated is not sufficient anymore because you added some things to the dynamic array, you have to copy all of the memory that was previously allocated to a new location. And if you use something like an arena or a page allocator, you have a problem because you cannot use this memory anymore. So I wonder if they use a general purpose allocator for this dynamic thing. So this is kind of the things I'm not sure about if it's so nice, because it obscures a lot of things. But of course, if you know what it does, it's maybe okay. But at the moment, I don't really know what it does. We would have to look at it. So let's see, Odin dynamic array. Okay. So where is it? Dynamic. Yeah, we should have read this. Range based. Where's this dynamic? Popping. Must be enabled. Okay, that's at least good. It's not on by default because I don't believe it's generally a good idea to have dynamic arrays. Oh, what's that? With address operator. Okay, passing pointers, slides to dynamic arrays and maps. Okay. Address operators. Dynamic arrays are similar to slices, but their lengths may change during runtime. Okay, so slices cannot change their length at runtime, but they can have a dynamic, a runtime length. Resizable, and they are allocated using the current context allocator. Okay, what is the default context allocator? Implicit context system. So at this point, I see that this is kind of the same code, but it also has explanations here. So it would be better to look at this here instead of the code, I believe. Context, ooh, new int. What's the default? Temp allocator. So general allocations. It's an OS heap allocator. By default, the cont is an OS heap allocator. Okay, what does OS heap allocator mean? Is this just a malloc? OS heap allocator? Nope. Okay, Odin context.allocator. Yeah, what is the allocator? An OS heap allocator. What does that mean? Okay, that would be kind of interesting to know. What is the default allocator? What does it do? Okay, it's for general allocations. This has to be malloc, right? Okay, so this is an arena-based allocator, but this is malloc syscall. Is malloc syscall? Malloc is not a syscall. Yeah, this is kind of the thing. Yeah. What does it do? Is an OS heap allocator. What? What does that mean? Is allocators Odin. Mem virtual. Virtual arena can optionally expand through the growing variant. Yeah, that's okay, but what is the context using? isn't already an allocator. So what is the allocator? Oh god. You don't care about how long the data is valid, so long that it at least lives long enough until the next allocation. This is something they control with blah. Just a flavor shared lifetimes. Does not ever clear empty or temp allocator, and in fact is a global arena. So I believe the other allocator is something like a malloc. Context allocator Odin. Can we somehow see what it is? Allocators with a generic allocator. Yeah. Really can solve the problem. Something like the memory management code. For example, in the context of making a game, having an arena allocator can simplify allocations of any temporary memory because the programmer doesn't have to keep track of which objects need to be freed every time they're allocated. Because at the end of every frame, the whole allocator is reset to its initial state, and all objects are freed at once. Yeah. When an override happens, all call procedures will inherit the new context. Okay, so yeah, I believe it's this general it's a general purpose allocator. Allocator. Okay. Okay. So we can, yeah, okay, so this is probably not an arena. This is a general purpose thing, which, oh, which is kind of obscure because, okay, so most of the times people probably just want to use something, but using malloc free, probably not the best thing to do. And making this cost implicit, I don't know if that's the best decision to be made, but that is okay as long as you know the trade-off. Okay, let's actually read through this thing here. Okay, I believe we were here. So constants are entities, symbols, which have an assigned value. Entities. Okay, weird term. The constant's value cannot be changed. Yeah, that's kind of okay. Okay, so we previously asked why they did that this way. Why they did colon. And why they use colon for a constant. Probably because you just want another way of doing it, but and they didn't want to introduce a new keyword. So we'd have to read this article probably. But okay. Okay, packages. Consists of packages. A package is back to Java. A package is a directory of Odin code files. Okay. All of which have the same package declaration at the top. Good. Execution starts and so what if we make a directory? What if we make a directory test package, or we make a directory test. Let's go into test. Let's have test1.odin, and this is package. This is package test, and it has a procedure add proc. Good, and it also imports core fmt. fmt.print ln what is going on. We are in the add function. Good. So we also have another one that's test2.odin. Create that file, and this is package test typo, and it has a procedure sub fmt, and also imports core fmt into your print line. Oh no, this is a call to the function sub. What if we now go back and say Odin build test? Different package name expected. Test typo got test. The expected test typo. What if we call this again? What? It expected test typo? Did it read the other file first? Okay, now it doesn't have an entry point. Odin help. Odin build help. Odin build help. So how do you do library? Odin build mode. Build mode lib. Build test. Build mode lib. Oh, a to-do. We had a to-do, build mode static on non-Windows targets. Build mode lib. Oh no. Great. Build mode assembly, also interesting. Okay. Okay, so whatever. Test. If we now have a main.odin and we make it also package test typo and have a main procedure, we also we want to now call add and we want to call sub. I don't know if that just works. Odin build test. That works. Permissions denied. Yeah, what is going on? We're in the add function. This is a call to the sub. Why does it do a test.bin? And what is lsla? LAH. So test. Permission denied. Sudo. What? Oh, it's a directory. Oh my goodness, this was so stupid. It's the directory. Okay, good. We also see that this thing has 313K. This is pretty big. We have a C file. Pound include standard IO. So this is kind of the equivalent, right? That's not the equivalent, but also a new line. Client test.c LAH. A.out has 33K. This is 1/3 of a megabyte. This is huge. Can you make it more minimal? So what if we compile with optimizations? This is pretty big. Optimizations. Oh, minimal. Oh, size. And we'll test size. Still 151K. Why is it so big? How do you get the sections out of... Goodness, how do you get the sections? Get sections out of bin file. Object copy. List sections of bin file. Read elf. Read elf. Do we have that? We don't have read elf. Does object dump have this? Private header. Start address. Symbolize operands. Symbol description. Disassemble. Disassemble symbols. List of symbols to disassemble. Oh no. Can you list symbols? Show all symbols. Object dump. Show all symbols. Dang it. How do you invoke this? Wasn't this the right thing to do? Show all symbols. What? Object file dumper. What? Okay. Test runtime built in. What is this? What if I do? Disassemble all. Disassemble. Yeah, this. What? Startup runtime. It has an equal function. Another equal function. Another equal. Cleanup runtime. So this is all runtime code. We have a heap allocator. Okay, this will explain size. We already have a heap allocator when we don't do any heap allocations. Okay, that's kind of... Okay, it has a lot of... Show all symbols. Test, runtime. Just the symbols instructions. It said show all symbols. Symbol description. I don't get it. Disassemble symbols. Disassemble executable sections. Dang it. Print. No. Show all symbols. During disassembly. Okay. I see. Display the symbol table. This is what we want. SymS. Oh no, I forgot. I forgot how. Oh my goodness. SymS. Text. Okay. Calloc. Malloc. Great. What if we remove? Does test.bin still work? Look at how slow this is for the first time. Odin builds test. Okay. Okay, let's go back to the documentation. We kind of got hung up with all of this allocator stuff. Let's go back to the documentation. So what we took away from this little exploration is that by default the output, the compiler output, is 1/3 of a megabyte. What if we have a minimal file that doesn't even have this? So it's just the main. It's just the main procedure. It doesn't do anything. So Odin build main.odin dash file. And LSH 71K. Okay. What when we, so it's probably core format that's so big. 71K. And what if we just strip dash O size 51K? Okay, if we just have a minimal test.c with a C runtime library. Oh my goodness, please. Void. No optimizations. A.out 16K. Okay, 51K is still pretty big. Okay. Never mind. Good. So what's next? We skipped over a lot. Oh my goodness. Okay, I believe we were at import statement. So, okay, we can import something. It's pulling in the symbols. State where the input is meant to look. This is called a library collection. If no prefix present, the input will look relative to the current file. Okay. Reference a package by a different name. What? Import what? By convention, the package name is the same as the last element in the import path. Okay, I see. You can also name this, right? Export names. All declarations in package are public by default. Okay, great. I think that's a good decision. You can also make an entity private to the file instead of the package. Oh god. Sorry. Private file. You can also make an entity private to this file, to the file instead of the package. Okay. I see. Alternate package. Organizing packages. Packages may be thematically organized by placing them in subdirectories of another package as subdirectories of core image. Nesting these packages is helpful taxonomy. It does not imply dependency. Okay. Control flow. Yeah, we also looked at this. Okay, you can have to do for the single statement. We don't have to look at this again. You can iterate over strings. You can have ranges, yes. We can iterate over strings. We have slices, we have arrays. Good, we have also dynamic arrays, which is, I don't know. But you have to enable it with a feature, which is kind of nice. And you also have maps, which is also dynamic literal. I wonder if you can... So you can have maps, but they are already dynamic. Why do they do that? Why can't you just have a fixed size map? I mean, a map doesn't have to be dynamic. And obviously also they have the defer keyword, which is a very nice feature. Map Odin. Oh my goodness, language. Handling objects, maps. Hash maps. Okay. Okay, hash maps. I mean, a nice hat. If they have a nice hash map, kind of a good feature. Oh, okay. I saw this post. Handles are better pointers. Better pointers. Better pointers. No. Handles are better pointers. Odin. No, this is the follow-up. I don't want to. Oh no. Yeah. Yeah, whatever. We have a hash map. I mean, what I don't like about these things that are very implicit is the hidden costs. This is also something I don't really like about Rust. Like, Rust has all of this implicit stuff, like, and very obscure stuff. I mean, at least it isn't obscure in this way, in that you don't have a type like, for instance, a box in Rust. What the fuck is what is a box? I mean, even the name. Even the name is kind of weird. I mean, what does it mean? Box. And you have to put things into the box. Yeah, it's just doing a heap allocation. And I think this is also not the right way of doing things. Obscuring these allocations behind these implicit declarations, because it hides a lot of the cost. I mean, if I have something that allocates a lot of elements, we could just allocate something in advance, or we could Or we could also allocate each time through the loop, which is a lot more costly. But this box style, box new thing, and the new and delete keywords, they're incentivizing that, which I don't really like. Okay. That's okay. Yeah, whatever. We got distracted again. Okay, we have maps. That's nice. If we're just hacking something together, probably something very convenient. For reverse iteration. Reverse iteration. Okay, you can also do reverse. Cool. Okay, so they add this pound something. I don't know if they use this consistently. This pound. This tells. Reverse. Yeah, it adds something. Something. I don't know how I feel about the pound. But how would you do it differently? I don't know. Okay. Odin's if statement do not need to be surrounded by... Yeah, we also saw that. And you can also have declarations. Okay, that's also nice. Because it's only then limited to the scope of the if statement. You can have switch statements. Switch arch. Okay, you can also have declarations inside the switch statement as well. That's good. And this, I believe, has to be compile time, right? Is this compile time? Switch statement is another way to write a sequence if, yeah, blah, blah, blah. It's basically a indirect branch. You branch based on the value. Odin switch is like the one in C or C++, except only runs the selected case. Okay, that's a difference. In C, you fall through if you not state a break statement. In Odin, you break automatically. And you have to use fall through explicitly if you want to execute the next thing as well. Okay. This is also a big difference between switch. I think what many people get wrong about the difference between switch and if is the fundamental underlying premise, which is also a little bit weird. Yeah, which is also obscured by some of these language features, which is x less than 0. I mean, this is typically not what a switch statement really is. It's weird. It's weird. Switch statement without a condition is the same as switch true. are clean and long if else. So this is basically an if else statement. They're kind of mixing things up here. I don't know. I mean, you don't. What I wanted to get to is that switch and if are fundamentally different. In that a switch is a branch based on the value. It branches to a different instruction in the instruction stream based on the value it switches on. So if we switch on an integer, we branch. Yeah, kind of the compiler does the compression of the table, but it's basically a table-based. It's a table-based branch. You look up the branch, the target instruction in a table. Whereas in the if else, you test something, and if the test is successful, you branch to something, and if not, you continue. That's fundamentally different. And what it does here is it kind of intermixes if and switch. Which, yeah. See? This is this optimization I talked about into jump table. So what you have is let's see if we can pull up. Oops. Like this. xcolordrawer.com. Okay. Now I have to plug in my. Yeah, that's kind of bad news because something has to go now. I believe I have only 2 of these. Yeah, that's kind of unfortunate. Something has to go. Maybe we connect our Bluetooth. I mean, it would be a good thing to switch. I'm gonna quickly connect my keyboard via Bluetooth. So that I can use my drawing pad to hello? How do you connect? Please connect me. Ah, God. Glove 80. Connect. Yeah, we're connected. Woo. Okay, so next, I also want to charge this. Let's see, one second. Good, let's plug the drawing pad in. Okay. So does that work? Does that work? Yes. Does this thing work? Good. Let's switch the scene. Very professional, without hotkeys. So if you have a switch, in C, you switch on, I don't know, switch on an integer. Like you have an int, C, and this is coming from some function. And we're now switching on the C. And now we have a case where C is 0. And we do something. Oh no, that's wrong. Case 0 here. And then we break. We have case 1. And we also break. We also have a default case. Or maybe not. I don't know. Okay, and what this compiles to is it looks up in a table. You have a table. How do we draw this? We have an array with locations. Okay, we have an array with locations. And what we do now is we look up this value. We look up the location we jump to in the instruction stream based on the thing we got in the switch. Like if this is 0, we index into this table, we look up the location. So we say in x86 assembly, for example, we move into RAX, for example, from this memory location. Let's say this is an RDX, the base pointer, RDX, and then plus RCX, I don't know. And RCX is the thing, so mov RCX, the C. Yeah, this is the C here. And then we move that in, and then we do a conditional branch. I don't know if that really works. Jump. Can you jump to a register content? That's something. Jump to register content x86. I don't know. Jump to register. Yeah. Since now we have to provide. Yeah. Jump. Yeah. So it's something like this. You can probably also provide I don't know, the resolved memory location or something. Or this directly, I don't know. But an if else is very different. Because you do compare something or test or whatever. RAX, RCX. This is basically a sub, but it doesn't do anything, and then you jump if not equal, jump if not 0, or jump if 0, and then to some location, to some fixed location. And otherwise you do something else, you add whatever, or I don't know. That's very different. But what Odin does here is kind of intermixing those concepts. Okay. I mean, it's just convenience. This is just a different way of expressing this. Also, no curly braces around here, which is also interesting. Okay, you can also switch on enums. That is good. Oh, you can also not have hard-coded. Okay, case. That's kind of interesting. So in this case, the compiler might not be able to do this table-based thing because it doesn't know the value here. Maybe it can if it's the same value, or if it's one of two values, or one of three. I don't know. But okay. A partial switch. What is a partial switch? Okay, partial switch. Probably you don't have to be exhaustive. Okay, good. Switch underscore in F. What does that do? Switch underscore in. It doesn't even explain that. Okay. With union types. Okay, foo is this. The switch is on the type of. Okay. Okay. That's all right. The following would print 4, then 2, 3, 4. Okay, defer, yes. Okay, good. 2, 4, yeah, good. Print 4, then 2, 3, 4. What? Okay. You can also have a defer block and a defer if. That's cool. Defer if. That's kind of a cool thing. Defer close. OS error none. Okay, this is kind of the error handling thing. Which is based on, which is kind of like Go. We check this error value. It acts akin to an explicit C++ destructor, however, the error handling is basic controlful. Yeah, error handling should be basic controlful. Okay. This won't affect n. Yes. This won't affect n. What? Cannot be used to change the procedure's named return values. And it runs after exit when the values have already been returned. Okay, it runs after exit. The defer concept differs from Go's defer, which is function exit, and relies on a closure stack system. Okay. That's good to know. The when statement is almost identical to the if statement, but with some differences. Each condition must be a constant expression as a when statement. Is valid at, okay, we have a compile time statement, which is when. The statements within a branch do not create a new scope. The compiler checks the semantics and code only for statements that belong to the first condition that is true. Okay, an initial statement is not allowed in a when statement. An initial statement is not, okay, I don't know what that means. initial statement is not allowed in when statement. It's probably an assignment or something. When statements are allowed at file scope. Okay. The when statement is very useful for writing platform-specific code. Yeah, it's kind of like if-def, yeah. If constructs and C preprocessor, yeah. Is type checked, okay. Conditional compilation section, okay. Branch statements, break, we already saw that. That is nice that you can break to a label and that you have labels. This is kind of annoying in C because you have to use gotos. Okay, with fall through, yeah, great. Procedures is something that can do work, which some languages call functions or methods. A procedure, literal, and Odin is defined with a proc keyword. Okay. Already saw that. Okay. It's kind of a constant. You can look at this as a constant assignment to this type. Okay. Good. Share type. When two or more consecutive parameters. I mean, we are good. Everything is passed by value. Great. Immutable values. All parameters are immutable values. Okay, so this differs from Rust as well. I believe these things here, yeah, as I said, these, if you assign something, that is mutable. But these things, they're not mutable, okay? Okay, they do that for calling conventions. Passing pointer value makes copy of the pointer, not the data it points to. Yeah, that would be kind of weird if they did that. Next, we have like pointers in this case. They're structured that contains values which include pointers, and the structure is passed by value. Yeah, okay. To mutate the procedure parameter like in C, an explicit copy is required. Yes. This can be done through shadowing the variable declaration. I thought shadowing was not possible. But shadowing... Okay, I don't know how to feel about this. Again, they probably didn't want to introduce a new keyword. You can have varx. I wonder how they implement that. They have var args. Okay. Good. This is also good. Very weird that you can only return structs or something, run value of one type from a C function. This is so much better. Maybe named. So if there are treated as variables defined at the top of the procedure, like input parameters. Oh, this is nice. This is nice. You don't have to declare them. Cool. Named arguments. When a calling procedure is not clear in which order parameters might appear, therefore the arguments can be named like a struct literal to make it clear. Okay, so varargs. Let's go back to the varargs. You can iterate over them. Okay. It's dot.int nums. Okay. Okay, but can you have any type varargs? This would mean you can only have ints. Okay. Create which R parameters might appear. Therefore, the arguments can be named like struct literal. Why would the procedure not be able to infer this? Okay, you can swap them around. Yes, okay. You can have default values. Positional arguments are not allowed. Okay. Mixing named and positional arguments is not allowed. This is often useful when a procedure has a lot of arguments. Oh, you want to customize default values. Are not allowed after name arguments. Okay. The default values. The create window procedure may be easier to use if default values are provided. Okay. This is good. Procedure overloading, very nice. Ooh. Two-string. You can have both. Okay, why did they do that? I mean, you could have one two-string and another two-string with the same signature, a different signature, but they did that. Explicitness and simplicity. Implicit procedure overloading complicates the scoping system. You cannot nest procedures within procedures, so all procedure lookups are done at the global scope. In Odin, procedures can be nested within procedures, and as a result, determining which procedure should be used in the case of implicit overloading is complex. Okay. I wonder why it is complex. Yeah, okay. I can see why. Okay. I don't know. Okay, explicit overloading has many advantages. I wonder which. Explicitness of what is overloaded. That's kind of a tautology. Able to refer to a specific procedure if needed. That is true, but I don't know why would you ever do that? Clear scope, the entity it belongs to. Okay, I will use specialized parametric polymorphic procedures if necessary, which have the same parameter but different bounds. See where clauses. Okay, I don't know. Basic types. Uint pointer. Why does it use uint? Okay, int and uint, I get it. But why uint pointer? Why not upointer? Or pointer just? Again, you can have endianness. You can specify the endianness. And you can also have 128-bit things, which obviously has to be emulated. A complex number, okay, quaternion, also been built into this. A rune, assigned 32-bit integer. Okay. Raw pointer. What's the difference between uint pointer and raw pointer? Runtime type information specific type. Okay. So do they put like JAI, the type information, into the executable? Wonder if they do that. Is pointer sized are natural register size, which is greater than or equal to the size of a pointer. What? Is that true? A pointer is 64-bit on a 64-bit 64-bit architecture, but a register is not greater than 64-bit on a 64-bit architecture. I wonder if that's a mistake in the documentation. C-string is used to interface with foreign, okay, libraries. The 0 value null for pointer, type video, and any types. Oh, they have any types. Good. Type conversion. Okay. Or type inference. Like C. Reply. Okay, good. The cast operator can also be used to do the same thing. Okay. Transmute. This is nice that I have an explicit thing to transmute something. This interprets the underlying value as the other thing. In C, you have to cast something, the address of something, to the address of the other type, to reinterpret the underlying bits. You can just use transmit here. Yeah, this is the same thing. See, you cast the address to this float, to an address to U32, and then you dereference it. Good. I like that. Untyped types. Untyped types. That's untyped types. Okay. In the Odin type system, certain expressions will have an untyped type. An untyped type can implicitly convert to a typed type. What? Will implicitly convert to bool, B8, B16. Okay. Autocast operation. The autocast operator automatically casts an expression to the destination type. Good. Building constants, values, and procedures. Good. False, true, null. Okay, this is good. This does the 0 as initialization thing. If you want to leave it undefined, you have to explicitly do that. I think this is the better way of doing it, because it leads to so many bugs if you do this in C. You just declare the thing, it's initialized, and it bites you in the butt all the time. If you're sure, you can just use the minus for undefined. Okay. The Odin string type is a raw pointer plus a length. Good. Coin conversion. Format printing. LNM. Where does that come from? LNM? I wonder what that is. Whole buffer is a string. 0 terminates string. String with length determined by n. And use %q rather than %s. What? Oh, this is the way you specify how this is gonna be formatted. You can put formatting on structs. That's kind of nice. C style string value, yes. 0 terminated, char const star, yes. Either convertible to an Odin string. However, to convert a string to a C string, it requires allocations if the value is not constant. Good. String type conversions. User show a list of possible type conversions, including whether they copy or alias. Untype string to C string. Action stream. ST. String to roots. Okay. We don't need to look at all of this, I guess. From. Okay, what is this? I believe this is a many pointer. This is just raw. Is it a raw pointer? Yeah, this is a raw pointer. I see. Kind of the same as in Zig, just that the Zig uses a star. Okay, you have the big shifts, remainder floored, modulo, blah blah blah. Okay. And nod. Comparison operators, good. I believe they also had something on arrays. Address operator. A at foo 1 2 3. And this is how you dereference it. Okay, it puts it after. Okay. If count else, yeah. It has bit sets. Okay, I'll be back in a minute. I have to go to the toilet. Oops. I hate it that you can't zoom on this. Okay. So, this is convergence, integer overflow. Integer overflow. Okay, overflow does not cause a runtime panic. A compiler may not optimize code on the assumption that overflow does not occur. For instance, good, okay. Floating point operators. Okay, we have assertions and distinct types. This is what we were talking about earlier. That you cannot pass the same thing to the to a function and not get a compile time error. Array access is bounds checked by default, both at compile time and at runtime. This can be disabled and enabled at a per block level with a no bounds check and bounds check directives, respectively. That's cool that you can disable that, because sometimes you don't want to have you don't want to have every time you access the array a bounds check if you check the length once. Okay, array programming. This is something nice, I guess. Okay, so you can just add them, you can multiply them. That is very nice. If you have fixed size arrays, you can just do plus times, and you can also compare them. You can also swizzle them, which is nice. Built-in implicit swizzle fields are available on any array with length less than or equal to 4. Good. It's kind of cool array programming things. Question is if you can use SIMD on these as well. Slices are like references to arrays. They do not store any data, rather they describe a section or slice of underlying data. Internally, a slice stores a pointer to the data and an integer to store the length of the slice. That is nice. Slice for literals. Yes, slice shorthand. Okay, 0 through. That's the kind of thing you do. Nil slices. Okay, because the pointer. Dynamic arrays. We already looked at those. Inject assigned to a dynamic. Inject. Inject at 0, 10. What is this? 0, 16. What does this make do? So length. Make 0, 16. I don't know why it does that. The length of x, the capacity of x. This prints all values, which is inject at 3. A 10. The length is 4. Oh, it resets. I see. Okay. I see. and it inserts zeros. Removing from the dynamic array. Or remove. Okay. Yes. That kind of makes sense. If you remove from the end, you don't have to move every element back. Just reserve with the dynamic array. Small array. Yeah, this is on the stack. Enums, okay. You can also specify the underlying type. Cool. Iterating an enumeration, what? Enumerated array. Enumerated arrays allow the use of an enum to be used as indices to a fixed array. Okay. This is neat. Okay. Bit sets. Bit sets element can type can either be an enumeration or a range. A through C. Bit sets are implemented as bit vectors internally for high performance. High performance. The zero value of a bit set is either nil or empty set. Oh, you can do that. It's kind of nice. Yeah, I mean, if you have a bit set, you can pretty easily implement flags if you want to. I don't know what the cost is. Oh, it's pointers memory address, yes. That this Pascal thing, yeah. Structs, good. Good. Struct literals. Okay, where are we? Okay, so there's a lot to go. I don't know if it's a good thing to go over all of these. What I wanted to look at, map container calls. Yeah, we don't need the map right now. Bit fields. Bit packed struct. What? Bit field U16? What does the 3 mean here? Bit field is different from struct in that you must specify the backing type, yes. But why do you have an I32 here or an U32? or bool. This is kind of weird. This is weird. v.x is 3. Accessing will convert v.x to an i32 into an appropriate sign extension. Okay. Kind of nice that you have them, but why do you have these weird... I don't know. What is nice is that you can specify how many bits this is. A procedure type, yes. A call, blah, blah, blah. Okay, right. Calling conventions. Odin, default convention used for an Odin proc is the same as cdecl, but passes an implicit context pointer on each call. This is subject to change, okay? This is the same as Odin, but without the implicit context pointer. The standard call convention. Most calling conventions exist only with foreign Windows code. The default calling convention is Odin unless it is within a foreign block. Type ID, yes, that's nice. By the any type. Versus any data type. Internally, it contains a pointer to the underlying data and its relevant type ID. Yes. Any value is only valid for as long as the underlying data is still valid. Passing a literal to an any will allocate the literal in the current stack frame. I recommend that you do not use this unless you know what you're doing. Its primary use is for printing procedures. Yes. Multi-pointers. Yeah, that's just a raw pointer. SOA data types. This is also what is present in Jai. SOA, this is the underlying array of structures of arrays. SIMT, single instruction, multiple threads. Multiple SIMT? What is SIMT? Hello? Still there? SIMT. SIMT programming. Multiple threads. Okay, weird. This is basically how the struct is laid out in memory. If you have a struct with ABC, then they are continuous in memory. But if you have an SOA and a structure of arrays, it is A, B, 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 C, 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 D, 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 D. If you access A, if you do accesses over these things, it will be, and manipulations over these things, it will be more efficient because you already have them in cache line. Yeah. But it depends on the use case. But it's nice that it does that automatically and you don't have to do that manually. Yeah. How do you do that SOA thing? AOS, this is all AOS. SOA, yeah. I mean, if you access all of them at a time, if you always access ABC, it wouldn't really make sense to lay it out this way. SOA zip. Which allows the user to treat multiple slices as if they were part of the same data structure, utilizing the power of SOA. The matrix type. Okay, there's a matrix type. Built into Odin is a regular array of numbers arranged in rows and columns. Element types of integers, flows, and complex numbers are supported by matrices. There is no support for booleans, quaternions, or any compound type. Yeah, okay. Okay, so multiplication is built in. Yeah, that's kind of a nice thing to have. I don't know how they do that. What the algorithm is. Probably not multi-threads, probably pretty standard algorithm. Column major. Why do they do column major? Like normal arrays, matrices try to maximize alignment to allow for the symmetry, blah. Yeah. We have built-in procedures. Okay, there's linear algebra in this. The using statement, I think this is a big one as well. Using can be used to bring entities declared in the scope namespace into the current scope. Using foo. Okay, this can be applied to input names, yes. I think this goes further. I saw this language demo talk from Jonathan Blow and it was pretty powerful. Yeah, see, this is now a frog. I mean, this is just polymorphism, right? You put it in here using entity, blah. You can also do it with pointer, I guess. Or else, or return. Call it true. Okay, you can see, you can check the error. Okay, great. If it's nil, you return the error. You can return. That's the same thing. It's nice. Or continue. Or break. Work until job done. Okay. This is nice for checking or break. Command line defines. Good that you can do that as well. Build tags. Okay, this is a build tag. This plus what we were wondering before. Build tags using statement using param. Okay, I have to plug my laptop into the wall, otherwise it will run out of energy, out of electrons in its battery. Great. Okay. Implicit context system. Yeah, you can have allocators. We looked at this before. Logging system. Foreign import kernel. Foreign system. It's sometimes necessary to interface with foreign code, such as the C library. In C Odin, this is achieved through the foreign system. You can import a library into the code using the same semantics as a normal import declaration. Okay. The Odin compiler can also automatically build and link imported assembly files, depending on the host system. Clang, as, or NASM may be used to compile the assembly. Okay, recognize file extensions for assembly or ASM, S, and S. Good. Using a vendor library. As described in the foreign system, we often want to use existing C libraries. Odin is a wide collection of maintained bindings and ports. Case notation, blah blah blah. Okay, GLFW. Parametric polymorphism. Or generics. Okay, can have generics. This is interesting. This is interesting. So parapoly is usually used. Okay, explicit parametric polymorphism means that the types of the parameters of a proc or of the data type of the data fields of a struct when intended to potentially be used with multiple possible types must be explicitly provided. This is similar to how C++ allows the use of templates to fill out the body of a procedure or the data structure with the types that are given at compile time as inputs to the template parameters, but an Odin explicit parametric polymorphism is safer and cleaner to work with. Okay. I wonder why that is. Procedures using explicit parametric polymorphism, parapoly. As a reminder, all parameters passed into a function are immutable in the sense that they can't have their value changed using the equal operator directly. A useful idiom is var equals var variable which expresses a variable sharing itself. When used at the top of procedure, the compiler understands the use case of enabling local modification of the otherwise immutable parameter variable and won't complain about the shadowing when you compile it with VET. So VET is a feature plus VET, not using statement, not using param. Or what does that mean? Plus minus VET. VET. I don't know what VET stands for. However, to specify that a parameter must be a compile time constant, which is not the same thing as an immutable parameter, and may sometimes be necessary for or desirable, the parameters must be prefixed with a $sign. The following example takes two compile time constant parameters. Okay, you can have compile time things. The types can also be explicitly passed by specifying that the type ID parameter is constant. Okay. Data types use explicit parametric polymorphism. Structures and units may have polymorphic parameters, and the syntax for doing so similar to procedure calls. Okay. So this is not necessarily useful because you don't know which functions you can call with this. Do we have to like in Rust there's this where keyword where T implements something. Yeah. See, this is here. Specialization. In some cases you may want to specify that a type must be a specialization of a certain type. It has to be a slice. Type specializations of table. Okay, they avoid. There are specializations of table. Okay. A bound on polymorphic parameters to a procedure or record can be expressed using where clause. Okay. Type is integer. Selector call expressions. Is called the selector call expression operator. So this is usually dereference in access of a variable in C. For call procedures stored in V tables. Okay. V table, a function lookup. General attributes. Linking. Okay, proxy. What is coming? Okay, a lot of things here. What to do if you get stuck? Okay, I believe we have somehow a good feeling of what the language is about. We don't have to read all of this. raw union. Yeah. Okay, I already forgot how you even write a union. Where was that? I'm a little bit tired. Union. And bool. Okay, this was this, yeah. Okay, it seems reasonable. This is an error. Oh no, now it's Odin built main.odin dash file. This is an error. Good. I believe we should build something with this language. Okay, so what if we just write a basic merge sort? Atomic compare exchange. See, there's all of this. Question mark string. What is question mark string? So this is the cast. See, there's so many things. Worker proc. So threading, they seem to have something for that as well. Thread. Can create a thread or remove. Ray programming. SIMD, /SIMD. Okay, so what if we just build something with this? Sort.odin. Okay, this is how you define this thing. So unsorted array. And probably needs a type. Colon equals or int. It was the other way around, right? Can we just do question mark here? 1, 2, 3, 4, 5. Okay, sort this. Let's just let's just see format.print. How can you just print this unsorted array? I don't know if that works. Whoa, that works. So if I do this, is it still? Okay, I don't know what the question mark means. Let's search for this. How do you get the type again? How do you get the type of something? Type ID? Type ID? Typed ID? Type ID? Okay. Cat cast. Okay, how do we get the type ID right? Type ID. Type ID off. A type ID off. Expected to type for type ID off. Shit. Oh, it's type off. Okay. Type off. Oh, type to procedure arguments. Countersign. What? Is it not possible to print this? I believe base runtime. Do you have to import this? Import base runtime? No. Okay. Type ID off. Type ID off. Okay, why? What? Okay, it's not the same type. Okay, it's not the same type. So the question mark is for getting the size. Okay, what if we do this? Okay, let's format print ln unsorted, or just call it array. And make it a 10 int. This should be 0 initialization, right? Yeah, it's all zeros. Good. Let's just make a 1024 int array on the stack. Good. Or we could also use make. So how do we do that again? Make. Call to make. Make Odin. Odin builds. Odin language. It's a little bit annoying. Where's the docs? Let's Can we search docs? Drawing packages. I don't know. Make. Oh god. Make slice. Ooh, type ID. This is slash. Okay. Let's look at demo. Let's look at the, okay. So what is this? What is this value? So sometimes you have just one, you count. Sometimes you have 3 arguments. Length, call location. Okay, that's length and capacity. Okay, length and capacity is it? Okay, what we want to do is this, right? We can also do this. Should just infer it. And 2024. We can also probably change the allocator. Context dot temp allocator. Does that work? Good. And free all. Okay. We probably don't need that. Okay, so we make this array. And now we need some randomness. Random. How you do random? Random. Get random. POSIX random. Get random. Random numbered Odin lang. Let's see. Math. Random dot choice. Random generator. So the context also has a random generator. Okay. Random. What? Get random, math, big random, S random. No. Just want to get random numbers. Random number generator. Choice. Choice enum. Rand float 32. Rand. So what we want is probably import core math and rand. Okay. What we want to do is for L in array. Is that right? Rand dot int. Does that work? Int is not declared by rand. Okay, so how did this work again? it was something like for this. You can write arrays and slice by reference with the address operator. Okay. Cannot dereference L of type int. How did the make work again? See, I'm not very fluent. int 32. God. How do you get a random integer? Random integer. Odin lang. There's a random integer. Generates random integer. Int max. 63. Why is it called int max? Int 63. Great, okay. So it's called int max. Parameter of type n. It's not provided. Int max 16. 2, 6. I don't know. Cannot assign to L. Okay. And then we want to sort this array. We also probably want some scratch space. This is probably how you do it to 512. Is this the way you do it? Okay, then you have a sort procedure. Takes an array of int, a left of int, a right of int, that's a uint. Let's make it u32, and also scratch. Zero length of array -1 and scratch. Does that work? Undeclared. Oh yeah, that's completely correct. scratch is equal to scratch 0 through 512. Okay, cannot assign. Is it like this? U32? Good. Hello. Hello, Edu the King. Welcome. I should probably look at the chat sometime. Right. Where is my okay? Let's just make sure this all works. So we print it before and after. And let's see. So standard merge sort, if left is equal to right, return. We want a mid, which is left plus right over 2. Then we want to merge sort the array from left to mid, and we want to also scratch from mid plus 1 to right. Make this inclusive. Okay. Then what we need is a right. It's gonna probably be calculated. I don't know. Passed as a parameter. I don't know. We need the right length, which is equal to the right. The right minus the mid, and the left length, which is equal to the mid minus the left plus 1. And then we also need an index, a right index, I call it int. I believe in this demo thing, colon int. Colon int. Okay, they do it like that. Colon int and a left index. Okay. Then we have to look at both halves. We have to have a for loop in which we need the index, and the right index has to be less than the right length, or the left index has to be less than the left length. And we increment I by 1. And then we have to check if right IDX is less than right length and left IDX is less than left length. We say scratch at I is equal to, so left. This could be a pointer. Yeah, I don't know. Right value is equal to R, right IDX, right plus right IDX. no, mid plus 1 plus right idx. Left value is equal to left plus left idx. If right value is less than left value, scratch is equal to right value, and we have to increment the right idx plus equals 1. Otherwise, the scratch right, left, oh, good. Else if the right idx is less than the right length, and else. Good. And finally, we have to copy for an array. Is it like this? We say L is equal to scratch at id. Okay, let's make this a U32, U32, R. Always name this R, and I failed to name it R at the very top, so. Oh, also, this is wrong. Right value is equal to R at mid plus 1 plus right idx. And left value is equal to R. Again, did the same mistake. Array add left plus left idx. Undeclared name merge sort. I thought this was right. Obviously, it's not right. Just a bunch of zeros. Oh my god. Oh no, it shouldn't start at array. It should not start at array, it should start at left. Left to right, but right is inclusive. Can you do that? Expected colon out of range. Right plus 1. Okay, it works. Let's make it a little less model. Let's N 1024. Let's make it smaller. Let's make it 16. I mean, it's probably better to do this 2 times. Okay, it sorts. Sort of, haha. That's kind of nice. And then you can also do free all. I like it, I like it, I like it. Okay, great. So I believe we leave it at that. We looked at the language and we implemented the merge sort. So small program. I believe we will continue this and make a marginally bigger project than a merge sort and see how it goes. I think Odin is a good language, has a lot of features built into it, which are very convenient as far as from what I can tell at this point. There are some things, quicks and turks, where I think, maybe it's a bit too implicit, although it states it's very explicit, like the dynamic array thing, uses context. Again, but many convenience features while being simplistic, and I believe that's the goal, the ultimate goal of it. Yeah, I like it. So far, I like it. We'll see how it goes.